So factoring by grouping is the method that we use whenever we have a polynomial with 4 or more terms. It's not always going to work for all polynomials. Again, not all polynomials are actually factorable. But if it can be factored, the factoring by grouping method is a really useful method to do so. But first, a quick review on exactly this process. Because remember, when you're multiplying two things, like 2x squared minus 3 times 4x plus 5 like this, we're going to take the 2x squared and distribute that. And then the minus 3 and distribute that. The idea is that we take each individual piece of that first binomial and distribute it to the second. So 2x squared times 4x is 8x cubed, and then we get 10x squared, and then we have minus 12x, minus 15. And that's it. That would be the multiplied out version, the fully expanded version. There's no common like terms to combine. Factoring in general is this exact process in reverse. Finding or figuring out this step from the polynomial, getting to this, and observing the fact that the 4x plus 5 is in common, pulling that out as a binomial GCF, and leaving the 2x squared minus 3 as the other factor. That's how factoring in general works, and that's pretty much how factoring by grouping is going to work as well. So the first example we want to talk about, that I want to talk about, is 7x to the 4 plus 6x to the 3 plus 28x plus 24. This will be our first example. The first thing that we always want to check for when we're factoring is to see if all of the terms in general, if the whole polynomial has the greatest common factor we can pull out. 7 and 6, actually we can stop there. They don't have a factor in common. I mean, 1 is a factor, but that doesn't count. X to the 4, x to the 3, x, there's no x here, so no, there's no GCF. The whole polynomial doesn't have a greatest common factor. But you might notice that pairs of the polynomial do. The 7x to the 4 and the 6x cubed, for example, we can take an x to the third out of them. If we extended that red line all the way to 28x, we would have only been able to take out an x. The factoring by grouping method actually works exactly what we're doing here. Instead of trying to take a GCF out of a whole polynomial, we're going to group pairs of terms. Take a GCF out of pairs of terms. That's how this process works. So we pair up the 7x to the 4 plus x to the 6x to the third. And we pair up the 28x plus 24, and we look for a GCF in those individually. So I can take an x to the third out of them. I have 7x plus 6 left. And then 28x plus 24, maybe you've already noticed, but we can take a 4 out of them, and we're left with 7x plus 6. Great. This is kind of what we were looking for. This is important to us, because now we have a situation that looks a lot like what we had up here. Here, we had the common binomial term of 4x plus 5 and 4x plus 5 that we were able to cancel out, or pull out rather, and show that we have the 2x squared minus 3. We're going to do the same thing here. Because that 7x plus 6 and 7x plus 6 is a common binomial term, we can get 7x plus 6 as a common term, and that means that the x to the third plus 4, that must have been the other binomial. Just like we have the 2x squared minus 3 breaking apart to get 2x squared times 4x plus 5 and minus 3 times 4x plus 5. The process can be reversed. And so this is our factored form. This is the factored version of that original polynomial. And this is how factoring by grouping works. We pair up the terms, pair up pairs of terms, and take a GCF out of those pairs. And hopefully what's left is a binomial in common. If it doesn't work out, then that probably means that the polynomial is not factorable. But check to make sure that if you don't get an exact pair of binomial terms here, I shouldn't say terms, an exact pair of common binomials, that maybe you didn't quite take the GCF out of one of them. So pay attention to that. We're going to do another example. feel free to skip ahead. (100x to the 7 minus 350x to the 6 minus 50x to the 5 plus 175x to the 4. This is the polynomial that we'll try to factor. And it looks intimidating because we have really big numbers. But remember, we always look for a common GCF first. Try to do the GCF factoring for the whole polynomial before we start pairing up terms and just looking at what we could take out of them individually. Always, always, always look for a common GCF first. Looking at these numbers, the coefficients, 100, negative 350, negative 50, positive 175, you might notice that 25 is in common in all of those. So I'm going to be able to take a 25 out. X to the 7, x to the 6, x to the 5, x to the 4. I could take an x to the 4 out as well. So that's going to leave me now with 4x to the 3rd minus 14x to the 2nd minus 2x to the, well, 1, so just x, plus 175 divided by 25 is 7. And now we look at what's left. Whenever you use or finish using one type of factoring, check to make sure that you can't use another type. We did the GCF factoring. Now we're going to look at what's left here and see, is this something that I can factor more? So that's what we'll look at. Again, we're going to factor by grouping. 4x cubed minus 14x squared. Well, I can take a 2 out of both the 4 and 14, and I can take an x squared. So that's going to give me 2x squared. And then that'll be 2x minus 7. Now we have negative 2x plus 7. Now, negative 2 and 7, they don't have a common term. They don't have a common factor. But remember that 1 is always a common factor. If that's the only thing that can be taken out, especially if you're trying to use factoring by grouping, then that may be the only thing that you can do. In this case, we can do a little bit better by observing that this negative 2x here and positive 7, they don't have the same sign, but in general, we want to avoid having the first term in anything. If this the first term, the leading term here in the original polynomial, or the leading term in any grouping, if the leading term is negative, always take out that negative. What I mean is that I'm going to take out a negative 1. And you'll see why this should make sense, actually, because ultimately I'm going to get a 2x minus 7, a positive 2x minus 7. I have a negative 2x plus 7. And if I divide those by a negative 1, well, now that gives me the 2x minus 7 that I would hope for. This 2x, 25x to the 4, just drops down. Once we take it out as a GCF, it doesn't disappear, but it just kind of comes along for the ride. And now we have 2x minus 7 as a common binomial term there. 2x squared minus 1 then is the other binomial. And that's it now. 2x squared minus 1, it does have two terms in it, but it's not a difference of squares. If you've already seen the difference of squares video, you'll recognize that. But if you haven't watched it yet, then go check it out now, or maybe in a moment after you check out the other one, for an exact explanation on what's happening there. But this is it. This can't be factored any further. 25x to the 4 times 2x squared minus 1 times 2x minus 7. That's the fully factored form, the FFF. I sometimes call it the BFF for best factored form. But anyway, that's the final answer. The final answer for our original polynomial.